Okay, on Learning Workbook page 219, there is one more logarithmic equation of type 1. Let's solve it now. Solve for x. Log base 9 of the difference x minus 2 minus log base 9 of 2 equals log base 9 of 19. Okay, so the first thing that I want to point out to you in this particular problem is that we have two logs that have a number for the base and the argument. Whenever you see that, you should always stop, think, and ask yourself, can that be rewritten in a simpler form? Log is EGOB. A logarithm is a missing exponent. So what is the exponent that goes on base 9 to make 2? Answer? I have no idea. 9 to the 0 power would be 1. 9 to the first power would be 9. I don't know of a nice, convenient number that I can rewrite this as. All right, how about what is the exponent that goes on base 9 to make 19? Does that work as some nice, convenient, rewritten number? And the answer is no. 9 to the first power is 9, and 9 to the second power is 81. Okay, we tried. Sometimes it works. And when it does, it saves you a lot of time and effort. But in this time, it didn't work, and that's just fine. So we'll solve this using the type 2 method. Okay, so I'm going to fix my problem here so it looks the way it did before I did all that writing. So let's solve this problem. Every term is a log, and they all have the same base. That makes this a type 1 problem. My goal is to combine these into a single log. And there are a couple of ways that we can do that. So in this particular problem, I notice that on the left-hand side, I have logs being subtracted with the same base and no numbers in front of the log. So by the quotient property, I can combine these two logs into one by using a fraction. The numerator will be the argument of the first log, and the denominator will be the argument of the second log. So I get log base 9 of this fraction equals log base 9 of 19. Now this is in the correct form. Log base something of something equals log base same base of something else. So by this property, I can now set these two arguments equal to each other. And I get x minus 2 over 2 equals 19. All right, we're going to clear this equation of its fractions by multiplying both sides by the least common denominator, which happens to be 2. So we're going to multiply by 2 here and here. When we do, these 2's cancel. They both turn into the number 1. Anything times 1 is itself, anything divided by 1 is itself. So I get x minus 2 equals 38. Adding 2 to both sides, I get x equals 40. Now, this might be the answer, or it might not. I have to check it. And the way I check it is by going all the way back to the beginning and replace all of the variables that I see with numbers. Well, the only variable in this problem is x, and it says 40, so I get log base 9 of 40 subtract 2 minus log base 9 of 2 equals log base 9 of 19. Of course, 40 minus 2, those are just two numbers. We can subtract them. So this gives me log base 9 of 38 minus log base 9 of 2 equals log base 9 of 19. I can combine these two logarithms using my quotient property. So this becomes log base 9 of 38 divided by 2 equals log base 9 of 19. And indeed, 38 divided by 2 is 19. These are equal to each other, and therefore I keep the answer x equals 40.